In this slide, we'll now deal with e minus an times cosine bn un. If we already know cosine bn un, when we multiply the signal by e minus an, a decaying exponential, then there is an interesting property that we can exploit, and this is the property. So let us now try to see how to exploit this property. If we have the z transform of ft to be f of z, the property says that if we are multiplying e minus an with f of n, and we are taking the z transform of this whole thing, then simply we use f of z that we have known before and replace f of z by ea, z times ea. And when we do that, we'll get the z transform of e minus an times f of n. Let's use a concrete example. In the last slide, we have already found the z transform of cosine bn to be this guy. So the property says if we have e minus an cosine bn, and we are taking z transform of this, simply replace this is f of z by f of z times ea. So let us try. So for every z that we identify, we are going to replace it by z of times ea. So zea minus cosine of b divided by zea squared minus 2 zea cosine of b plus 1. Let's compare. This expression is the z transform of e minus an times cosine bn. So it looks exactly the same. And now we want to check how did we arrive into this from the beginning. Again, we use the Euler's identity to represent the cosine. This is the Euler's identity. We are going to use e minus an multiplied by cosine bn, so we put the e minus an in front. We can distribute e minus an into the cosine, and we get this expression over here. Again, we use the linearity to perform the z transform individually. So this is the z transform of the first expression, the z transform of the second expression. The 2 here goes out as half. So we work out the algebra. It is not difficult but troublesome, so do it carefully, and we'll reach the final stage here. The equation don't look the same. You'll be wondering, and why is this so? So to reduce from the last line, second last line to the last line, this is what you must do. Multiply top and bottom by e to a. Let us see what happens when we multiply the expression at the denominator by e to a. We'll get here e minus 2a times e to a is 1. Here 2z e minus a cosine b times e to a will get 2z e plus a cosine b. Z squared times e to a will have z squared e to a, and this reduces to zea to the power of 2. So the denominator works out. We now tackle the numerator. This is multiplied by e to a. Z of ea times z of ea is equals to z squared. So we have the z squared here. Multiplied by e to a. The second one is e minus a times e to a. We'll have e plus a. So we have e plus a times cosine b over here. So the numerator also matches. Typically, we will not ask you to do this unless it is a question to derive. We'll expect you to jot down the property and exploit using this property whenever you encounter such an equation. Thank you.